Hello, I have an email asking a couple of questions, and so I figured I would answer them here. Other emails might come in asking about things, and that's fine. I'll just do this, and I would tune in to all of these to see, and unless if you're not getting something right, you want to tune in to see what's going on. This is almost as if we did meet in class today. I would be able to clear up your questions at the beginning of the period. So a couple of questions. One was on number 8 from the partial fractions. And the question was, why was my answer in the end the natural log of 3x plus 1 over 3 plus c? And the question was, why do I have this over 3 situation? That is because I'm taking the natural log of something that's not just x, of something where x has a coefficient in front of it. So I'm going to just explain over here. If I had the integral of the natural log, pardon me, if I had the integral of dx over x, that would just be the natural log of x. If I had the integral of dx over x plus 2, this will be the natural log of the absolute value of x plus 2. But if I have the integral of dx over 3x plus 2, this is going to be the natural log of the absolute value of 3x plus 2. But I need to divide by 3 as a way to undo the chain rule. Technically, what I'm doing is using substitution. For a problem like this, technically, I'm letting u equal 3x plus 2. And therefore du is 3 dx. Because I don't have a 3, I'm going to have to multiply my problem by a 3 and therefore by a 1/3 to make up for that. So that this problem becomes 1/3 times the integral of du over u. So I have 1/3 times the natural log of the absolute value of u. That's where that 1/3 comes from. It's basically doing substitution. But I don't want to do substitution every time. It's just a lot more work. It takes a lot more time. So I want to get into the habit of seeing that when I have to take the integral of something that just has a coefficient with my x, nothing more, that I don't have to use substitution. I can just think about undoing the chain rule, that I can divide by that derivative of x, which is just 3. So it's the same thing as when I would have like the integral of cosine x is sine x. And the integral of cosine 2x is sine 2x over 2. I don't go and do substitution every time. I just know that, okay, I've got that coefficient of the x and I have to divide by it. So that's what's happening there. So that was a question on the partial fractions. I ended up with a factored form on the bottom that had a 3x plus 1. So I needed to divide by that 3. Okay, there was also a question on the integration by parts. One of the questions was in number 2, I said in the classwork, I picked u to be the natural log of was it y or was it x? I'm not sure. And I said that was abnormal, that was like not, what did I say? It was an exception that u was natural log of y. The reason I said that was the integral was, I'm just going to make it x. I think it was x, but now I forget. I had said in the original integration by parts that I usually want to pick u to be the thing that will decrease in power. So u is usually x or sometimes x squared. The thing that will reduce in power as I take the derivative of it, eventually going away. But in this case, I don't have anything that like decreases in power. I don't have any x. I only have a natural log of x. So this is a unique situation. I have 2 parts to this problem. I have a natural log of x and I have a 1. These are my 2 parts. So I can't let u equal dx or 1 dx because the derivative of that would be like, first of all, 0, and it wouldn't work. So in this case, I have to let u equal the natural log of x and dv equal 1. So that the derivative of u is 1 over x and that v is x. So it's just a special case. It doesn't come up a whole lot, but what was cool about it is it allowed us to take the integral of the natural log of x, which we hadn't been able to do thus far. The other question was on number 5 from, I think, the integration by parts practice problems. And the question was, this person had the answer as the natural log of the absolute value of cosine u, but I think I had the negative natural log of the absolute value of secant. Well, these two things are the same. Doesn't seem like it at first, but this negative in front, it's like there's a -1. Log powers tell me that multipliers can become powers. So log rules, log rules, logs rule, Log rules say if I have 5 times the natural log of x, this is the same as the natural log of x to the 5th. Okay, that's one of the rules of logarithms, that a coefficient multiplier can become a power. So here, what really happens, if you want to think about these being the same, is this -1 can be thought of as a power. And then what is secant to the -1st? That means 1 over secant, which is the same as cosine. So this is the same as the natural log of cosine. So these two answers are the same. Either one is fine. But if it were a multiple choice question and you had this and they only had this, you would feel confused. This is actually the best. This circled one is the way you'll actually see the answer on the AP test. So sorry if I wrote this and didn't go that last step. But yeah, you'll see it written that way, but both are the same. Okay, hopefully that cleared up some questions for you. And hopefully you watched.